Good morning. We are going to start with a new lecture today. The weather is nice and we are going to talk about the climate. And with a big hope that the climate is not going to change in that direction, that we cannot enjoy our conferences in Dubrovnik. Today's speaker is Madame Natasha Markovska. She has a doctoral degree from the Faculty of Electrical Engineering in Skopje. At the present, she's a senior researcher and a professor at the Research Center of Energy and Sustainable Development of the Macedonian Academy of Science and Arts. She's a member of several international and national professional bodies like National Focal Point of the Intergovernmental Panel of Climate Change, IPCC, International Scientific Committee of the Conferences of Sustainable Development, it's us, is a steering group of human resource and mobility, and she chairs a national committee on climate change. She has been participating in numerous international and national projects related to climate change mitigation, renewable energy sources and energy efficiency, energy strategic planning, as well as mobility of the researchers. In this field, Dr. Markovska has authored a number of published contributions, and since 2015, she is a member of the editorial board of the International Journal of Energy and elsewhere. She served as the editor of the second national communication under UNFCCC and as a guest editor of special issues of international journals. She has her speech is going to be about the climate change mitigation with the challenging title, Will We Make It? So, Natasha, will we make it?
Thank you. So, thank you, Professor Roginski, for the excellent introduction and posing this very challenging question. Happening in the run-up of the Paris 2015 Conference of Parties, this lecture, in fact, is going to highlight the requirements from technological, economic, and institutional point of view regarding the mitigation scenarios which are behind the global goal of limiting the global warming below 2 degrees compared to pre-industrial levels. So it will be mainly based on the findings of the Working Group 3 of the Intergovernmental Panel on Climate Change, IPCC, presented in the 5th assessment report, which was adopted last year in Copenhagen. So the lecture will address the past trends and the factors that drive emissions over various sectors, including primarily technology, GDP, or population growth. Also, I will put some highlights on what should be done to limit the global warming below 2 degrees, and some mitigation measures and policies which are undertaken within and over different sectors of economy will be also addressed and discussed with particular emphasis on low-carbon technologies, because it turned out that these technologies have a major role on our decarbonization pathways. Also, some prerequisites for effective mitigation will be presented with an emphasis of the role of science, what the science should be done in this endeavor. And finally, this will bring us to present to some recent developments regarding Paris 2015, which somehow will provide hints to this will we make it questions. So the past trends and driving factors of the emissions. Greenhouse gases emission growth has accelerated despite reduction efforts, and clearly seen from these figures. So despite a growing number of climate change mitigation policies, annual greenhouse gases emissions grew with a rate of 2.2% annually in the last decade, compared to 1.3 percentage rate in the previous 3 decades. So the total anthropogenic emissions in 2010 have reached the figure of 49 gigatons CO2 equivalent. And although we have this global crisis, 2007 and 2008, it has just temporarily reduced the emissions. In terms of the ones we should blame about this, it's clearly that the main part of these emissions are associated to CO2 reductions from fossil fuel combustion and industrial processes, this yellow part of the chart. So over the last 4 decades, total cumulative CO2 emissions have increased by a factor 2. You see, about half of the cumulative anthropogenic CO2 emissions between 1750 and 2010 have occurred in the last 40 years. From 900 gigatons, after 40 years, they have increased to 2,000 gigatons. And greenhouse gases, over the regional patterns of greenhouse gases emissions are shifting along with changes in the world economy. And here you see that significant changes have been occurred in the energy sector and industry sector, but also in all other sectors. The only sector which has not seen some increases is land use sector. And what is the striking effect that this considerable increase have occurred in upper mid-income countries, which is the growing Asia, and where a lot of developments and infrastructure and expansion has taken place. Globally, economic and population growth continue to be the most important drivers of increases in CO2 emissions from fossil fuel combustion here. The contribution of population remained roughly identical all over the time, but you see here the contribution of economic growth has risen very sharply. This dark blue part. And between 2000 and 2010, increased use of coal relative to other energy sources has reversed a long-standing pattern of gradual decarbonization of the world's economy supply. Increased use of coal, especially in developing Asia, is exacerbating the burden of energy-related greenhouse gases emission reduction. And here you see, we have in all previous decades this negative introduction of negative changes of this factor, carbon intensity of energy, in difference to the last decade when this factor introduces positive change in annual emissions. So this is a very striking obstacle and barrier on the road to decarbonization. So, what should be done in order to limit the global warming? Limiting warming involves substantial technological, economic, and institutional challenges. Without additional mitigation, global surface temperature is projected to increase by 3.7 to 4.8 degrees over the 21st century. And it's not all about climate change. There are many other extreme events which could also hinder our planet. And here you have them listed with the different level of additional risk due to climate change, ranging from undetectable to very high. And the current business as usual pathways which will address all these, will include all the happening of all these additional events with high to very high level of risk. Stabilization of atmospheric greenhouse gases concentrations requires moving away from business as usual, which corresponds to higher concentrations than 1,000 ppm CO2 equivalent. This corresponds to business as usual scenario, and here is the full set of scenarios considered in Assessment Report 5 of IPCC. And so, if we consider mitigation scenarios corresponding to limit of 2 or 2 degrees, 3 or 2 degrees increase in global temperature, they will lead to requirement of much lower concentrations of CO2 into the atmosphere. 2 degrees with 430 to 480 ppm CO2 equivalent concentration in the atmosphere, and 3 degree with a little bit lower ambition, leading the concentrations to the values between 580 to 720 degrees. But as can be seen, there is an overlapping between these two level of ambitions, meaning that lower ambition mitigation goals require similar reduction of greenhouse gases emissions. And as I mentioned at the very beginning, the mitigation involves substantial upscaling of low carbon energy. And here we have the figures for the 2 degree scenario, where in order to be achieved, we need 3 times increase in share of low carbon energy technologies into primary energy. And of course, this upscaling of low carbon technology holds true also for a lower ambition scenario of 3 degree increase, requiring increase in the share of low carbon technologies of 180%. And let's talk about the timing of mitigation, which is also a very important component of the overall mitigation effort. And here you see the pathways of emissions before 2030. So we have a wide spectrum of scenarios which, after an immediate action, meaning that we have acting just yesterday and now and even more tomorrow, we have to have this decrease of emissions in the period of 2030 to 2050 of 3% per year. And in terms of share of low-carbon energy, it means that we need substantial increase of 90%, so almost double the share if we want to achieve this 2 degrees scenario. And what will happen if we have a delayed mitigation, which somehow corresponds to the current pledges of the world put at Cancun Conference of Parties? So they somehow imply delayed mitigation, meaning that we leave some time for action, but then we have to act more actively and more intensively after 2030 to 2050, meaning that we have to reduce the emission at much faster pace with 6% annual decrease rate. And in terms of share of low carbon energy, this 90% in immediate action will grow to 240% in the case of delayed action. And at the end, in 2100, we see that we have to achieve some similar levels of share of low carbon energy. So it means that delayed action is out of question because it implies increased mitigation challenges for limiting warming to 2 degrees relative to pre-industrial levels. What are the mitigation measures and policies which mature and currently have been used within different sectors and within and across various sectors? So it became quite clear that low stabilization scenarios depend on a full decarbonization of energy supply. And just for illustration, here you see baseline scenarios for the emissions as we have the highest growth in the electricity sector, and we have steady growth in all other sectors except for the sector land use change and forestry. So in this sector we have emissions in the electricity sector in 2100 achieving to 80 gigatons CO2 emissions. What will be required by the 2 degree scenario? So this is at this slide, the case is presented where we have a mature carbon dioxide capture and storage technology. And we see that 2 degree scenario leads to total decarbonization of electricity sector, carbon-free power generation, even with negative emissions in 2050, and a very highly negative emissions in electricity in 2100 in order to achieve these 450 concentrations of 450 ppms in the atmosphere. But of course, this is one of the scenarios considered where the case of maturity of carbon capture and storage technology is assumed. But also, there are other scenarios which can somehow fulfill this requirement for 450 ppm CO2 equivalent in the atmosphere. And then the major role will go, in this case, with the land use sector, when it will take the role of withdrawing the overshooting of CO2 equivalent in the atmosphere. So you see all the negative emissions are occurring in the sector land use. And of course, this scenario also involves significant endeavors in all other sectors, including electricity sectors. And here, again, we have carbon-free, almost carbon-free power generation in 2050 and totally carbon-free power generation in 100. We also have significant decrease in the emissions and required endeavors in all other sectors, transport, buildings, industry, and sectors which emit no CO2 emissions. So, so again, all these findings stress out the fact that decarbonization of energy supply is a key requirement for limiting warming to 2 degrees. But, and here on this slide, we have technologies which can be applied in order to achieve this goal. And here, a share of all these technologies into the energy supply in 2050 is presented, and we see that all of them have a role to play. But besides that, we also have, in order to ease the decarbonization pathway, and even to enhance, we also have to introduce energy demand interventions. And they can provide, beside that, flexibility, hedge against risks, avoid lock-in, and provide also co-benefits. And on this slide, you have the share of all these low-carbon technologies into energy supply, given under the condition that substantial effort is undertaken on energy demand side. So we see that all the shares of these low-carbon technologies compared to the scenarios without energy demand technologies are much lower, meaning that a great part of investments, mitigation investments, will be transferred to energy demand side. And here is the share, the difference in the final energy demand reduction relative to baseline in both cases when we have 2 degree and 3 degree yellow bars, and in under 2 degree scenarios blue bars, and we see different final energy demand reductions relative to baseline scenarios. These are a number of studies which indicates all these potential related to energy demand actions and behavioral changes. So the wide-scale application of best practice low greenhouse gases technologies could lead to a substantial emission reduction. And on this slide, we have put some example from electricity generation. There are a number of low emission technologies, but as you can see here, we have a different level of emission intensity of each of these technologies, with a leading role of wind, solar, wind, hydropower, and so on. And on this slide, we have the cost of electricity based on high full load hours. And of course, besides that, we have also introduction of electricity market into place, which will certainly change the picture in favor of the technologies which have zero or minimal marginal costs in favor of solar and wind. And technologies are here. Just for example, we have recently faced the PV revolution with dramatic drop of the price of this technology. Also, the growth of installations, wind and photovoltaics is depicted on this, and we have a very steep increase of the installed capacities of these technologies. And finally, a grid parity, after all, has been achieved in 102 countries all over the world. So in 102 countries in the world, we have the situation when installing PV on your house and producing your own electricity is cheaper than to buy electricity from the network. So it's happening. In terms of costs, yes, mitigation costs estimates vary, but what has been shown that this is not a very big burden to the overall world economy, because the global GDP growth may not be strongly affected. And this slide shows global costs rise with the ambition of mitigation goal. So we see a rise in the cost of mitigation in various ambition goals, but we see that the difference between among different ambition level is not so visible. Also, some technological limitations can increase the mitigation costs. And here on this slide, we have a calculation of increase in mitigation costs relative to default technology assumptions. For example, in the case when we have no mature carbon dioxide capture and storage technologies. So it means that in a lower ambition scenario, the mitigation scenarios will cost almost 50% more than the case when we have mature of this technology. And even in more ambition scenario of 2 degrees, this dependence is very visible, and the cost will rise almost 150%. With nuclear phase out, we also have some increase of the mitigation costs, but they are not so much significant, as is the case with the limited solar wind potential and limited bioenergy. Yes, mitigation by itself, maybe it cannot be so attractive, But if we consider the co-benefits, it can also make a case of mitigation and provide motivation to politicians and to general public to undertake the mitigation actions. So on this slide we have the impact of stringent climate policy on air pollution emissions in various scenarios. So we see even 50% reduction of air pollution in the case of 2 and 3 degrees mitigation scenarios. And also, it is not only related to air pollutant emissions, but also to ppm pollution. And here you see the impact of mitigation of ranging medium high to very high all over the world to the PM10 pollution. So it can be seen that these mitigation and air pollution reduction goes together hand in hand. And it's not only the air pollution co-benefit. We also have a good, excellent potential in generating jobs related to low carbon technologies. And just on this slide, see the comparison between solar PV and coal-fired and natural gas-fired technologies in terms of their potential of generating employment over a lifetime of facility. In the case of solar PV, it's about 7 to 11 jobs per megawatt of installed capacities, while in the fossil fuel-based technologies, this figure is about 1. What are the prerequisites for effective mitigation? Of course, it has been shown that technology is there, but what then is needed? Changes in investment patterns and appropriate policy. That would be the first answer, and it is clearly indicated on this slide, where we have negative investments, considerable negative investments in extraction of fossil fuel and fossil fuel power plants without carbon capture and storage. Negative investments meaning displacement of investments in this field over the time. On the other side, we see considerable scaling up of investments into energy efficiency across various sectors. Investments in total electricity generations and divided by renewables, nuclear power plants with carbon capture and storage. So mitigation efforts considerably changes the investment patterns over the energy technologies. And what else has been seen, that there has been a considerable increase in national and sub-national mitigation policies since the 4th assessment report. And here you see comparison between 2007 and 2012, where we have and here is a global distribution of various climate policy across the world, and we see a number of climate change policies implemented in various countries. And compared to 2007, in 2012, we have almost 70% of total greenhouse gases emissions covered with climate change policies. in difference to 40 and something in 2007. This is a very, very striking and fact which somehow puts some hopes that with policies, with adequate policies, the world will turn on his development on a carbon-free pathways. So there are a number of sector-specific policies, and they have been more widely used than economy-wide policies. I will not here we will have presentation of all these different types of policies divided by type, be they governmental provision or public goods or services, regulatory approaches, economic instruments. I would just want to mention here subsidies of fossil fuels. They need displacement, and a number of information programs. And as you see, a majority of these policies are sector-specific in difference to a lower number of possible policies applied over the whole economy. And the third component of the question for how effective mitigation can be achieved, of course, is a science. Science for technology advancement and informed policy design. And I would say now that given the topics of sustainable development of energy, water, and environment system conferences, it's a great time for SDEWES scientists, because in all these endeavors, scientific endeavors, we touch the hot topics of science which are needed and which emerged from the requirement for effective mitigation. And those are no need to mention too much, to spend so much, but just briefly, better integration of wind and solar. Integration of power, heating, cooling, water and transport systems. Integration is becoming a buzzword. Also, advancing the technologies which will enable market arbitrage and time delay, power to heat conversion, power-water integration, will enable demand management, power to fuels. Also, we need technologies which will sort out the electrification of the part of road freight, shipping, aviation, and high-temperature processes. Biomass, yes, but we don't have enough. So, should scientific fuels will make their significant contribution in this endeavor. And of course, we need socioeconomic studies which will quantify the socioeconomic impacts of mitigation measures and policies, and will inform in a rigorous way our politicians in order to make a well-established positions about their climate change policies. And last but not least, it is international cooperation, which really matters and which really is a very important aspect of our endeavor to limit climate change. And of course, in the middle here, we have this UNFCCC process where all the countries at country level discuss their mitigation efforts and their mitigation policies, how to jointly deal with problem. But not only UNFCCC process, we have here a number of forms of international cooperation, ranging from international, national, or regional, or sub-national level, and jointly with the UNFCCC process, contributing in their own way to this process. And this brings me to the concluding part of my presentation, where are some last developments regarding Conference of Parties in Paris 21. So just all the countries, as several times was mentioned, now are putting their pledges, estimated their efforts, how they can contribute to the global effort to reduce CO2 emissions. And in the climate change terminology, those pledges are called intended nationally determined contributions. So in climate change terminology, this INDC word is a very important word. And if 2-3 days before we had like 50 INDCs submitted, just last 2 days, this number increased to 120 submissions. And here we have 148 parties represented, and the average of global greenhouse gases emissions of 85%. So this is very promising step. And of course, the level of ambition, it's very difficult to calculate because, and it's difficult to calculate, is it enough? Because all these INDCs have very different forms, targets very different gases, and so on. And it's not easy to have a uniform approach in calculation of their achievement, but still, the earlier calculations of beginning of September have shown that the expected greenhouse gases variation compared to 1990 levels within, at that time, submitted INDCs is 90%, plus 90%. So increase compared to 1990 emission in 2030 for 19%. And yes, as I mentioned, there are here some, I picked up some examples of submitted INDCs, European Union, at least 40%. So it's like a end-year type of target when the target in 2030 is compared to a specific year in the past, that is 1990. But also we have an examples, particularly in developing countries, when the achievements are measured in the year 2030, but compared to business as usual scenarios. And what is really important, and it was mentioned in the lecture of Professor Nakicenovic, that for the first time we have everybody engaged in all these international processes. In climate change discussions, not only in difference to previous situation when we had some quantified reductions accountable only for developed countries, here in this time also developing countries are entering the game, as is the case with the Sustainable Development Goals, when just several days ago we have adopted all the Sustainable Development Goals with compromise, so everybody agreed that they will come to achieve these goals in the near future. And the situation can be summarized that, yes, the commitment made and likely to be made by December will not by themselves be enough to achieve the 2 degrees goal. What can be done to improve the situation? Yes, to engage not only the government, but non-state actors, cities, local governments, and businesses. Yes, it's not easy, but there is no other option, because it might be turned out, it might turn out that it is difficult the government to make an agreement. And also, INDCs should be subject to regular review and reaching it up in the years after the Paris meeting. So to see, yes, it is not enough, and to push the governments to make much higher ambition, to put some higher ambition level into their pledges. Yes, the other important issue is the financial part of the deal. Who will going to pay? Of course, the developing countries require developed countries to pay. But it is not, yes, they don't say no, but they want to have a very strong control over how the money assigned for mitigation will be spent in the developing countries. Also, a lot of disputes over a number of issues. I will just mention loss and damage, where developing countries requires also payment for the other events which are somehow associated to climate change and make big burdens to their society. And yes, there are a number of questions still hovered over what would appear in the core agreement. So, will we make it? After all this, I could say that the idea of success might seem as a long shot, but the present action, the accelerated actions, bring hope that all the individual agents will advance their interests coherently towards the common goal of saving the planet. And yes, the science has a significant role to play by assessing the risks and options, by innovating technologies and devising new solutions, and finally, in a rigorous and policy-neutral way, informing the processes for reaching decisions. Thank you for your attention.
Thank you, Natasha, to bring us not a little bit, but more optimism in your question. So will we make it after this election? I truly believe that we are going to make it. But according to my point of view, the crucial part is the technology development. Of course, the politics is politics, but we have seen that the Kyoto Protocol has practically failed because it was based on the restrictions. We cannot calculate on the restriction on the world level, but we can calculate on the technology development. You have shown the picture of the photovoltaic with the drop of the price. So with the huge development of the technology, we can make it. Thank you very much. So the floor is open if you have any questions for Natasha. Oh, where is the microphone, please?
Thank you for such a wonderful presentation and the emphasis on the role of science for meeting the climate mitigation endeavor and the great role for SDEWES scientists. I would like to ask how better we can organize ourselves. Could we maybe open a questionnaire, solicit some ideas and some technologies, and because there's a very important expertise represented from many countries here. Or maybe even another idea, maybe a Delphi survey, we could do some of the technologies or targets. So how can we better organize ourselves?
Yes, it's a very viable question, but I think that you have shown us an excellent example of producing this SDEWES index. And if it is published in journals, if it becomes more visible not only to scientific public, but also to general and to policy makers, it could make a good progress in that. Yes, maybe some, I don't know, maybe some declaration should stem out from this conference to be delivered at conference of parties.
Like a position paper, maybe?
Like a position paper, yes. It's going to be, I don't know what the organizer can say on this, but yes, it is possible.
Thank you, Dr. Natasha, for the nice presentation. One question. You know, we are living already the climate change and the high temperatures, and we have to take urgent mitigation. The scientific community is divided. Some of the scientists are in favor of sequestration, others for conversion, and others for storage. And the technology or the solution of sequestration or conversion will not solve the problem, because it will solve small portion of the problem. So the only third solution that can make difference is the storage. However, many countries are against, you know, the carbon capture storage. So how do you see the whole scene and the future? What do you think? How this can be solved?
Particularly, I don't also believe in carbon capture and storage, personally. But yes, the solution, as shown there, it's not only one technology, but portfolio of many technologies. We know here that we have some overshoot of carbon which should be withdrawn, but carbon capture and storage is not the only one solution. There are many. So the right way probably would be a good and balanced portfolio of different technologies which will enter into place to resolve this issue. Yes, combination of all of them.
Yeah, Stefan Meyer, TU Graz. I'd like to add something. Like the technological changes will be very important, as you said, and you showed it very nicely. But I also think coming from these behavioral changes you listed on one slide, that has also to be extended to societal changes. And in a way, the population growth is also a very important topic, and I see very little in the total conference talking about that, because even though we are changing much with technological changes, still the population is changing, and we are running after that. So population growth and also growth in an economic way is an important thing. If you think about also pension systems, still also relying on Europe, which is not growing that, but it's still also growing. And so this has also be important facts added to this, what you said there, I think.
Yes, I fully agree that synergies above scientific disciplines, including also sociology, psychology, and many other social disciplines, is very important and has significant role to play. How to enforce the populations to make the changes in behavior. And it has been shown that substantial reduction can be achieved with these behavioral changes, and I fully agree that also we have to extend maybe the topics of SDEWES conference to include more inputs from these social sciences. Yes, I agree with you. Thank you for the comment, very valid.
Good morning, Prof. My name is Blessing Mavmishabi from Anglia Ruski. Thank you very much for the excellent presentation, and it's very insightful. Here, I want to make a case for developing countries, especially Africa. And from your slide shows that most of the African countries, they have no significant interest in the climate change mitigation measure, or because the researches on issue of pollution arise from majorly energy issue in that region is very, very gray. It's not well researched. And I believe from current research that have started recently that African buildings and industry, they might be, in quote, producing more emission than the world thought of. Because one, the issue of technology deployed in generating those energy. For example, generator use is increasing. And in my own current research, which is still ongoing, I find out that when I converted the diesel input and the PMS input using caloric value of these two types of energy source into the electricity conversion, I find that it was very high. And using the carbon factor too for respective country, normalizing them, I found that the emissions were really, really high. And I believe that if the world, in quote, want to solve, they want to be a general solution or mitigation measure, that more focus should be on developing countries who still use crude technology in harnessing energy and other form of production. Because the mitigation measures they are not channeled towards African country or other developing countries in part of Asia and other part of the world. So what is your take on this, please?
Yeah, for the developing countries, the main component could be not mitigation efforts of reduction, but maybe technology transfer. This component should be somehow stressed out. And developed world should support this technology and know-how transfer to developing countries. And also this technology transfer and diffusion of technologies is a very important component of the global deal. This is also what the countries are negotiating for. And I do hope that they will find a very robust and very significant and adequate mechanism how to enable passing a good and because it's let's turn it into advantage. Starting from beginning, it's maybe easier than to have technologies and to change and to go. So African countries and other developing countries have a better chance to go to develop and climate-friendly technologies from the very beginning. And of course, this transition should be regulated in a very adequate way with these international agreements.
Thank you very much.
Hi, just following on that, with what you said about the technologies being introduced into African countries, I absolutely agree. However, it should also be noted that a lot of the times the policymakers make the decisions and it's based on a lot of corruption. So it'll be very good when if the rest of the world places the, pressure on the on the politicians to make the right decisions. Then I just also have a bit of a more technical question. One of the slides you presented said something about job creation and that there's going to be greater jobs in the renewable energy sectors versus coal power. Does the coal power job creation take into consideration the coal mining sector? Because that's a very big sector in like South Africa. And if we lose that, we lose a very big part of our GDP creation.
The second question, yes, it takes the whole lifetime of the technology, including the extraction of fuel.
Okay, wonderful.
And the first question, yes, corruption, pressure, and all these things are also part of this sociological and social dimension of the problem. So, indeed, it's not only, yes, the technology and technical things and technical science are needed, but they must go hand in hand with also social sciences in order to have very valid solutions.
Great, thanks so much.
Thank you very much. So we are running out of time. So if it is one question more, no, it is not. Thank you, Natasha, for a very interesting lecture.